Okay, this is 6.3, simplifying complex fractions. So here is an example of a complex fraction as well as the definition. So a complex rational expression, also known as a complex fraction, is a rational expression whose numerator and denominator are both fractions. So let's write this down. We have x over 2y squared. And then we have the main division line. And then we have 6x, whoops, that won't work, 6x minus 2. That should be a 2. It kind of looks like a z. So let me write that better. Over 9y. So a complex fraction, that's what I'll probably call them more than a complex rational fraction, has 1, 2, 3 division lines, and the numerator is a fraction that accounts for one of the division lines. The denominator is another fraction that accounts for the second division line, and then we have the main division line. And of course it should be obvious it's right there. So basically the goal of this chapter is to simplify them. So the chapter actually represents or gives you two different ways to simplify them. And I'm going to give you a break. Maybe you consider it a break, maybe you don't. We're only going to look at method 2. And the reason it is I've emphasized, and most mathematicians do emphasize, clearing denominators by multiplying through by the LCD of all of the terms involved. And we've also spent quite a bit of time on finding the LCD of fractions whose denominator is a polynomial. So if you have already seen this by chance, and I do it differently than what you have done in the past, then you're free to look in the e-text on pages 362 through 363 and use that method there if it's the same method that you were familiar with. So here's the method we're going to use. We're going to first find the LCD of all of the denominators of, I guess I should say, of the denominator of the fraction that's in the numerator and the denominator of the fraction in the denominator. And then we're going to multiply both fractions, both the numerator and the denominator, by the LCD. So this is going to be best illustrated not by talking about it, but actually doing it. So again, here we go. Give myself some space. So I have 5x over x plus 2. I'm going to draw the division line a different color, the main division line I should say. And then I have 10 over x minus 2. So I guess the first thing to do is to take note of your main. This is the fraction in your numerator. It's 5x over x plus 2. And the fraction in your denominator is 10 over x minus 2. So, if possible, simplify. I'll call them the n fraction, which stands for the numerator fraction, or the d fraction, which stands for the denominator fraction. In this case, there's nothing to simplify. How would you simplify? You would factor out the greatest common factor. There's nothing to factor out in 5x, and x plus 2 is prime. There's nothing to factor out about 10, and x minus 2 is prime. So our first step is going to be, step 1, find the LCD of our denominators in the top n fraction and the denominators in our d fraction. So we want to find the LCD of x plus 2 and x minus 2. Well, since x plus 2 and x minus 2 are both prime, that's just going to be x plus 2 times x minus 2. And you do not multiply these out. Leave them factored. Leave in factored form always. So now what we're going to do is, this is my LCD right here, and I'm going to multiply by 1. I can't change the value of this expression, so I multiply by x plus 2 times x minus 2 divided by x plus 2 times x minus 2. And I've already run out of room, so I'll come down here and start all over. So 5x over x plus 2, big division line, 10 over x minus 2. And I'm multiplying this by x plus 2, x minus 2 over x plus 2 and x minus 2. So notice the numerator is the same as the denominator, so I'm just multiplying by 1 in disguise. And remember, 1 is the multiplicative identity. And then what do you do if you need to put parentheses around factors? That's fine. But we're going to cancel out like factors. So there's an x plus 2 here, and an x plus 2 here. There's an x minus 2 here, and an x minus 2 here. So now it's not really tricky. You just got to think about what you're doing. The top becomes 5x times x minus 2. And the bottom becomes 10 times x plus 2. Again, the same thing here is true that I wrote in red here. Do not multiply out. What we want to do is simplify. We don't want to multiply out. And it can be simplified because 5 divided by 10 is equal to 1/2. So this is equal to x times x minus 2, or 1 times x minus 2 if you prefer, over 2 times x plus 2. And that's our final answer. No further simplification can be done. Let's take a look at our next one. So these seem to be difficult. They're really not. They look nasty, but they're not. And the method I chose to teach you, I think, is, it's hard to really say if it saves you steps or not. So again, here's our problem. This is, I guess, 1b. So x over y squared plus 1 over y. So that's my numerator fraction. All of this is over that's my main division line, y over x squared plus 1 over x. So our first step is we have to find the LCD of all of the denominators contained in the numerator fraction, which is this right here, and all of the denominators contained in the denominator fraction. So I want to find the LCD of y squared, y, x squared, and x. So I'll go ahead and do this. It should be obvious to you, but some of you might enjoy or benefit from this. Our prime factors. And we have four things to consider. It's really simple, and I hope you're already saying, yes, I know what the answer is, but I'm afraid some of you may not. So that's the reason I'm going ahead and doing this. So our prime factors, when we have single variable terms, are just those single variables. That's x and that's y. And I have a y squared and a y and an x squared and an x. So how many factors of x are there in y squared? 0. How many factors of x are there in y? 0. How many factors of x are there in x squared? 2. How many factors of x are there in x? Just 1. How many factors of y? I mean, you could also go down to do y squared, y, x squared, x, or you could go across like I'm doing. How many factors of y are in y squared? There's 2. How many factors of y are in y? There's just 1. How many factors of y are in x squared? 0. How many factors of y are in x? There's 0. And then what do? We circle the largest number of each, and the LCD is equal to each of my prime factors raised to the largest number in the accompanying row. So my LCD is x squared times y squared. So again, I've run out of room. So I'm going to come down here and I'm going to go ahead and rewrite this. That's my, I wish I could copy and paste. To my knowledge, this program does not have that ability. But I'm also quite certain that I've not really looked super hard to find it. I have looked, but you know, maybe I looked like males look. You look for 2 seconds and declare it. I can't find it. Okay, so we're going to multiply the top and the bottom by our LCD. So I'm multiplying by a new fraction. X squared, y squared, x squared, y squared. So this quantity is 1, provided x and y are not equal to 0. And we're just going to kind of take that for granted that the variables used have values that make this a meaningful expression. So here we go. So notice, I'm going to come up here, and let's do x, y squared plus 1 over y times x squared y squared over 1. So I'm literally just using the distributive property. So x squared times y squared divided by y squared is x squared, and x squared times x is equal to x to the third. And I cleared the denominator. Literally, the denominators are going to be cleared. So x squared times y squared times 1 over y. Well, y squared divided by y is y. So x squared times y squared divided by y is x squared. y. So my top value is x cubed plus x squared y. I'm going to do the same thing down here. Maybe I'll come over here and do it. So I have y over x squared plus 1 over x, and that's going to be in parentheses, times x squared y squared. So I'm going to challenge you. I'm going to move over and give myself some more digital writing space. So I'm going to challenge you to try to figure out what this is before I do it, and that's how you learn. So y divided by x squared times x squared y squared. Well, the x squares cancel out, and all I have is y times y squared. So that gives me y cubed. I'm clearing denominators. X squared times y squared divided by x, which is the same as multiplying by 1 over x, is x squared divided by x gives me 1x, and then I have a y squared. So that's the answer that I put over here. Y cubed plus y squared x. Now over here I have x times y squared, but remember this is multiplication, so I can change their order if I so wish, and I wanted to. But I'm not done until I have completely, I'm almost there, and I need to simplify this. So what's the GCF of the denominator? Both terms have a power of x squared. So I can pull out my x squared. X cubed divided by x squared leaves me 1x. X cubed times y divided by x squared leaves me a y. Down here I have the greatest common factor is y squared. And I'm repeating exactly what I did up there to get y plus x. Now we're going to use the commutativity of addition. A plus b is equal to b plus a. So this is the same as x squared over x plus y divided by y squared. Y plus x is the same as x plus y. And now, as always, if we have a factor in the numerator that is the same as the factor in the denominator, it cancels. So that gives me x squared over y squared, which you can also write if you want using I think the quotient rule of powers x divided by y squared. I don't think that my math lab cares one way or the other. I don't think it prefers this over this. If it doesn't accept x over y squared, if you have something similar in your homework, give me an email and let me know. We're going to be reviewing our textbook selection for this class soon, and I'm already in the committee for doing that. And it's good to know criticisms or praise of the book you're using. So our next one is 2x. So I'm looking at this one right here. Example 2, simplify each complex fraction. I'm just going to go back to my drawing space and look over here at my notes. 27y squared. So notice there is no simplification that can be done for those two fractions. In my main division line, 6x squared over 9. So this can be simplified. So you don't have to simplify it if you don't want to, but I think it's always good to simplify at the first occasion. So since 6 is equal to 2 times 3, and 9 is equal to 3 times 3, we can cancel out the 3's, and we get 2/3. So this becomes 2x squared over 3. So now we want to find the LCD of our denominators in the numerator fraction and the denominator in our denominator fraction. So we want to find the LCD of 27y squared times 3. So the easiest way here, this is just, since y doesn't appear over here, this is just the same as the LCD of 27 and 3 times y squared. Well, the LCD of 27 and 3, remember it's always going to be greater than or equal to the largest of the two numbers, and it's equal to the larger of the two numbers if and only if the smaller of the two divides it. So this is equal to 27y squared. So that's my LCD. So let's go ahead and perform the simplification. So again, I'm multiplying by another fraction. It's 27y squared divided by 27y squared. It's going to make it easy because here those cancel out and all I'm going to have is 2x. Down here, notice again, just let's take a look at here. Let's come over here. 2x squared over 3 times 27y squared is the same as 20 times multiplying by 27y squared divided by 1. So 27 divided by 3 is 9. So this is the same as 2x squared times 9y squared, which is equal to 2 times 9 times x squared y squared, which is equal to 18x squared y squared. 18x squared y squared. So now all we do is simplify. 2 divided by 18 is the same as 1/9. So the 18 becomes 9. 2 becomes a factor of 1, which I don't bother to write, but I'm going to write it because my x terms are going to cancel out. So I need something up there. They don't go to 0, remember. So x divided by x squared leaves me 1x in the denominator and y squared. And that is as far as we can simplify it. We just did that one. We'll do all of these. I've got my notes messed up. I'm going to have to bring this down and copy it over. So this is, what, 2b? Something like that. So b over a squared plus 1 over a. And again, we're going to be dividing that by a over b squared plus 1 over b. So I want you to verify on your own that the LCD of a squared, b squared is equal to a squared, b squared. That should be easy for you to verify. All you have to do is go back to two problems, and we did one very similar to that, except my variables were x and y. So I'm going to multiply the top and bottom by a squared, b squared, divided by a squared, and b squared. So I'm multiplying. So this is equal to a squared times b squared times, so remember I'm using, it might help you all to put these in parentheses. I'm using distribution here. So a squared times b squared times b divided by a squared. Well, the a squared cancels out, and I get a b cubed. This is exactly the same. So, okay, stop. We're stopping here. This is the same problem as one B. Except, what is the difference about it? The variables have been renamed. So there's no reason to do this one again. Although you may want to. And A was X and B was Y, and the final answer was B over A in parentheses squared. I don't know why I have two there that are just the same. Maybe I don't know. So simplify expressions with negative exponents. There's nothing really new for this objective. We just use the fact that x to the minus n is equal to 1 over x to the n. It looks really nasty. When I say that, there's nothing really nasty about mathematics. It just means it looks different, and it's so odd looking that it seems as if it would be really complicated. But it's not. It may be surprisingly easy, as a matter of fact. So the first thing we will do here is we have to change this expression using exponent rules into a complex fraction or a rational fraction. And we have, what is that, x to the minus 2 minus x to the minus 2, y to the minus 1. So let's make the change. X to the minus 1 is 1 over x. 2x times y to the minus 1 is 2x divided by y. X squared to the minus 2 is 1 over x squared. This is a minus sign here. X to the minus 2 over y to the minus 1. Remember, we make both of those positive exponents by moving them across the division line. So I'm done with that. So now all I have to do is I need to find the LCD of x, y, x squared, y. Well, I want you to verify this is going to be the, whoops, x, y, x squared. I didn't write all my terms in there. X, y, x squared, here we go, x squared, y. Hold on just a second, it's raining. I'm going to let my cat in. Come on. I'll just leave the door open. I'll just leave the door open. If she sees it, she can come in on it her own. I think she just went and hid underneath my car. So the LCD, I hope you can verify, is x squared y. So you take the highest power of all of the individual variables, and the final answer has to be a product of both. She ran underneath the car, so I'm just going to close the door because it's a distraction. I like the sound of the rain, but I don't know if you all can hear it or not. So that's what we're going to do. I found the LCD, and it's x squared y, so I'm going to multiply this top and bottom by x squared y. So let's come down here and do that. So again, I'm going to caution you, for most of you, depending on your skill level, you need to make sure that you're turning the sums and differences into a factor by putting parentheses around them. Because you're using distribution. I'm literally taking x squared y, taking all of this, and I'm multiplying it by my first factor and my second one. So x squared y times 1 over x is the same as x squared y divided by x. So that leaves me an x times y. So this is literally clearing the denominators. At the end of this process, this sum right here that are fractions will become a sum with a denominator of 1. That means we don't even write it. We're clearing the denominators. So 2x divided by y times x squared y, where the y's cancel out. So I have 2x times x squared, so that's 2x cubed. And you can already see that these share a factor of x. So you know there'll be some simplification in the numerator anyway. Doing the same down here, x squared y times 1 divided by x squared. The x squareds cancel out, and I just get a y. And not plus, but minus is what our sign is. 1 over x squared y times x squared y is just 1. So that made it really simple. So what we need to do is we need to simplify our numerator by factoring out the greatest common factor. And the greatest common factor is x. So x times y divided by x leaves me a y. Plus 2x cubed divided by x leaves me a 2x squared over y minus 1. And no further simplification can occur. So let's do this one. Notice right here that the base of this is my 2x, and the 2 times x is raised to the minus 1 power. So this is number 4, just number 4, I think. Not that it really matters the numbers. We were given 2x in parentheses raised to the minus 1 plus 1 over 2x to the minus 1. This is a great problem. Minus 1. So the first thing we do is we rewrite using our negative exponent rules. So here our base is 2x, so to convert this into a positive exponent, I write it underneath the base, underneath the division line. And in this case, I'm going to add plus 1 is, I'm going to write 1 is 1 over 1 because I want it to be a fraction. You don't have to. And here the base is x, not 2. So this is 2, stays in top, and x to the minus 1 goes below the division line, minus 1 over 1. Now you don't really have to write these as fractions, but I went ahead just to emphasize that they are. And now what I just kind of want you to do this. I want you to automatically put these in parentheses. I'm just sensing that that's going to be helpful. But what is our next task? It is to find the LCD of our denominators, 2x and x. We don't care about the ones. We only care about denominators that are not 1. And I'm hoping you realize that that's 2x. So I'm going to erase this equals, because I'm not going to do anything that's going to require an equal sign, but I am going to multiply it by a new fraction, which is equivalent to 1, when the numerator and the denominator are the same, and I'm going to go ahead and do that. So again, this is using distribution. 2x, just like that, in case you weren't aware. So 1 divided by 2x times 2x is 1. And then 2x times 1 is plus 2x. Down here, 2x times 2 divided by x is 4. So 2x, 2 over x times 2x. The x's cancel and I get 4. And 2x times minus 1 is minus 2x. So there is something that we can do to simplify this. And you always have to simplify if there's anything you can do. And the thing you can do is you have to factor anything. And this can be factored. The greatest common factor in 4 and minus 2x is a 2. So that becomes 2 times 2 minus x. And that's all that can be done. And that is your final answer. And I think that may be the end of this lecture. Challenge, 2 challenges. Write example 1b with negative exponents. So which one is 1b? It's this one right here. Write it with negative exponents. Second challenge, how might one simplify a complex rational expression whose numerator is itself a complex fraction? So the numerator itself is a complex fraction. Would the same technique work for a complex rational expression whose denominator was itself a complex fraction? So these are just if you're bored and you want to check your answers. If you want to do these and you want to do both of them, you can send me your answers and I will give you extra credit in some way. Of course, your answers have to be correct. And I'll give you a hint for number 2. Same procedure. Okay.